What if I told you that solving any equation is just like being a detective? You have clues, you follow a pattern, and boom, you crack the case. Today we're solving the ultimate math mystery in Module 3. Think you can balance a seesaw? Well, equations work the exact same way, and I'm about to show you the secret that makes solving them feel like a game. Raise your hand if you've ever looked at an equation like 2x plus 3 is equals 11 and thought, where do I even start? Well, by the end of this video, you'll be solving this in your sleep. The number one mistake students make with inequalities. They forget one simple rule that flips everything upside down. Literally. Let me show you that 99% of people get wrong. Pause the video right now and try to solve this question. X plus 4 is equals 6 in your head. Got it? Great. Now let me blow your mind with why your method actually works and how to use it for way harder problems. I'm going to give you a superpower today. The ability to turn any English sentence into math equations. Ready to become a math translator? Module 3 is where everything clicks. Equations, inequalities, word problems, it's all connected. Stick with me for the next few minutes and you'll master the balance that unlocks every algebra problem. This is Mahmoud Kiasari. Welcome to Special K. Hello everybody, so let's get started. As I just promised, today we are going to talk about the third module, which is about equations and inequalities. So at this point we are going to talk about the balanced equation, map the solution, and after that on the problem itself. So let's see what are the objectives in this course itself. We are going to solve equations, as I just some kind of mentioned it before. We are trying to see that how we can solve two expressions where they are equal together, which we call as equation. We are trying to solve and graph inequalities, translate the word problems, and at the end we are trying to check that whatever the answer that we have is right or not. So let's talk. So let's talk about it. What is an equation? So first of all, the thing that we have to understand and be familiar is expression. What was expression? If you remember from our previous videos, expression contains three important parts. The first one is unknown, which we call it as variable. The second part is a coefficient, the number that comes beside the variable itself. And the third one is a constant. The combination of these three is going to give us something that we call this as expression. I told you that when we do have expression and that specific thing is just try to define itself, it's not going to give us any clue that how we can find that specific variable. What was the variable? Is something unknown. I don't know what is that. But if I can find a way in order to make one expression equal to another one, right now I have an idea that how I can find that variable. So in a nutshell, when we are talking about equation, we are talking about two expressions that in the scale, and we have to find a way in order to make them equal. So both sides must have the same value. For instance, when we are talking about x plus 3, actually this one is x plus 3 is an expression, and is equals to 7 is something that we are trying to find a value for x in order to make sure that this one is right itself. So our job here is to find a way in order to find that specific variable, which is x. So x plus 3 is equals to 7. So obviously you can understand that x is equals to 4. Well, what would happen if the problem is going to get a little bit more challenging? What we should do on that time? Don't worry about it. We are going to talk about it soon. So after that, we do have inverse operation. What does that mean? Imagine that I do have a condition that my x plus 3 is equals to 7 and I'm asking you, okay, find x for me. What would you do for the first time? So the very first thing that some kind of pop into your head is that, okay, I have to find a way in order to make that specific variable individual or make it isolated, and after that put other things beside that, which could be constant, the coefficient, whatever, should move to another side. what would happen on that time? On that time, I do have x is equals to something. I don't know about that specific something. I have to find a way in order to find that. Another thing that I have to mention is about the balance. If you remember from this scale, I do have one expression equals to another expression. So I have to find a way in order to move that specific number beside x to another side. In the meantime, I have to keep the balance itself, because again, I don't like to change the question. I still want to have the same question. In the meantime, try to find a way to solve the whole equation based on the x itself. So when we are talking about moving one number from one side to another side, or dividing one side by one number, and after that some kind of do it another thing, we have to keep one strict rule. Whatever you do with one side, you have to do the same thing with another side. Another thing that we have to be careful is that, okay, how we can actually do that? How I can know that at one point I have to do subtraction, at another point I have to do addition, at some point I have to do division, and at some point I do have the multiplication. I completely understand that when I'm doing one thing or one operation at one side, I have to do the same thing at another side. But at what point I should do that? So let's see. First of all, let's talk about inverse operation, which are the key moves. What does that mean? It means that if you would like to isolate a variable, as you just remember, I mentioned that we have to make our variable, our unknown, which could be x, y, z, whatever, into one side, or we have to keep it isolated. To isolate a variable, we have to use inverse operation. It means that we have to undo some bottoms. What does that mean? If we do have a number, as in that number is added, you have to subtract it. And if we do have a number that is multiplied, you have to divide it by another number. So what is that? Imagine that I do have an equation at x plus 5 is equals to 12, right? So as you remember, I told you that if you want to find the x, you have to make x isolated, right? So what do we have problem over here? X plus 5 is equals to 12. I have to find a way to only keep x. So at this point, I see that x is added with 5 is equals to 12, right? What is extra thing over here? Exactly. The extra part is 5. I have to find a way in order to get rid of that. What is the way? Since I do have addition, the only way that I can get rid of 5 is what? Is subtraction. And that subtract is inverse operation. It means that when you see addition on one side, you have to do the subtraction. If you see a subtraction on one side, you have to do the addition. Why we are doing that? Because we are trying to get rid of whatever extra is. At this point, 5 is extra, so I have to get rid of it. But I also have to be careful that when we were talking about the equation, when we were talking about the way to solve that equation, we were also talking about balance. So whatever you do with one side, you have to make sure that you're doing it with another side. So at this point, I do have 5 as an extra. It means that I have to find a way to get rid of this 5, which is subtracted by 5. So it's simple, right? But in the meantime, I also have to be careful that when I'm doing the subtraction with one side, I have to do it with another side as well. So it means that 12 subtracted by 5. What would happen at this point? At this point, this 5 is going to cancel out this 5. So I do have x. And after that, I do have 12 subtracted by 5, which is equal to 7. So I know x is equals to 7. As simple as that. So whenever you see addition, you have to do the subtraction. Whenever you see the multiplication, you have to do the division, and vice versa. Whenever you see the subtraction, you have to do the addition. Whenever you see the division, you have to do the multiplication. By this way, we are trying to keep our unknown isolated. Remember, all the time, the question is, what is the unknown, or what is the variable? We are not looking for 2x. We are not looking for 2x plus 5. We are looking for x and only x. So after that, let's start this idea with one-step equation. Actually, one-step equation was the last one. It means that the only thing that you have to do is either doing one addition, one subtraction, or one multiplication and one division. It's not that hard. Why? Because we are facing a problem that x is just alone. X doesn't have coefficient and constant at the same time. Either x is plus or minus a number, or we don't have that plus or minus. The only thing that we do have is 2x, 4x, 5x, whatever. So let's see an example over here. I do have x plus 5 is equals to 12, right? Just like the last one. I have to get rid of the 5 itself. 5 is extra, inverse operation. So I'm going to subtract it with 5, subtract it with 5. X is equals to 7. Simple. X minus 9 is equals to 3. I have to do the inverse operation and use the exact same number. Do the same thing on another side. What do I have? X is equals to 12. Simple. So by this way, I'm doing what? By this way, I'm just using the addition and subtraction and with only one step in order to find the x itself. Let's make it a little bit challenging. So what would happen if I don't have any constant and if I do have coefficients? So at this point, what is happening? At this point, still I have to find a way to make x isolated. Is that right? So how can I do that? I do have 3x is equals to 18. What is extra part over here? Exactly, that is 3. And 3 is beside the x. 3 is not adding, 3 is not subtracting, it's beside the x with something that we know as coefficient. So coefficient is actually a number that is multiplied by my variable itself. So I do have, actually this question was 3 times x is equals to 18. If you remember about the inverse operation, I told you, whenever you see an operation, you have to find the inverse of that. What is the inverse of multiplication? Exactly, that is division. So I have to divide everything by x, divide everything by 3, because 3 is extra 1, and do the same thing with another side. So if I do this, 3 is going to cancel out 3, and 18 divided by 3 is going to be 6. As simple as that. You see, it's not that hard, it's not that challenging. The only thing that you have to know is how I can make x isolated. So let's see another question. At this point, I do have x divided by 4 is equals to 3. Maybe you see that one question like this. X divided by 4 is equals to 3, still the same. Sometimes they're trying to show it as a fraction. Sometimes they're trying to show it as an operation. It doesn't matter. Both of them are the same. So I do have division. I have to use the multiplication. Times 4. Use the same thing. Times 4. So x divided by 4 times 4 is going to be a 4, is going to cancel out 4, and 3 by 4 is equals to 12. By the way, for some of you that you have problem with the multiplication and division of fraction, we also have some videos about it in this channel, and you can use it. Again, if you have any problem, just comment me down below and we can talk more about it. So at this point, we found out how we can find the x and how we can make it isolated. Either we have to use the addition and subtraction, or we have to use the multiplication. But what would happen that if we are facing a condition that we have to do both of them somehow at the same time? I mean, not at the same time, a different step, but still we have to have two steps. So at this point, we are going to face another type of equations, two-step equation. What does that mean? It means that at this point, I have to undo addition and subtraction first, then undo the multiplication and division in another form. Again, what we are doing, the thing is that we are going to combine the last two slides together. We have to get rid of a number, which is a constant, from the whole package, and then we have to get rid of the number that is beside our variable, which is the coefficient itself. So let's look at an example. I do have 2x plus 3 is equals to 11, right? What should I do? At this point, I'm going to do something with the easiest part. What is the easiest part? The easiest part all the time is addition and subtraction. Why? Because with addition and subtraction, actually, we are not going to change the first part of expression. It means that if I add something to my expression, I'm not going to change the 2x. 2x is still there. 2x, 3y, 4z, whatever. But the only thing that I'm going to do is to get rid of the easiest one, which is 3. How I can do that? By subtracting by 3. Still the same way. If it was x plus 3, I will do that. If it was x 2x plus 3, still I would do that. So I do have subtracted by 3 because I want to get rid of it. And what do I have? I do have 8. That was the first step. The second step is that right now I do have 2x is equals to 8. Again, remember, the question is asking for x. It's not asking for 2x, 4x. It's asking specifically for x. So what is the extra part over here? The extra part is actually 2x. What should I do? Again, remember, when I'm telling you that 2x is 2 multiplied by x. What is the inverse operation of it? The multiplication? Obviously, it's division, right? So what should I do? 2 multiplied by x is equals to 8. I have to divide everything by the number that I don't like. Everything by the number that I don't like. So this 2 is going to cancel out this 2. This 2 is going to 8 divided by 2 is equal to 4. And x is equals to 4. As simple as that. Try to see the 2 steps again in another form. I do have 2x plus 3. I have to remove 3 from both sides. So get rid of 3. I do have 2x is equals to 8. I have to get rid of 2. So I'm going to divide everything by 2. As simple as that. Again, why we're calling the 2-step equation? Because as you just saw, we had 2-step itself. So let's see what would happen if we do have a negative number. Again, I'm going to remind you something that I believe you already know that. So whenever we do have a negative number, multiplied by negative number, it would be positive. Negative multiplied by positive is going to be negative. Positive multiplied by negative is going to be negative. Positive multiplied by positive is going to be positive. These are some kind of the very basic rules about the positive and the negative numbers, that in total about the sign numbers. So what would happen if I do have a condition that the number beside x is not going to be positive, it's going to be negative? So everything is going to change just a little bit, not that much, but we have to be very, very, very careful because at this point, something would change. So imagine that I do have a question that negative 4x plus 5 is equals to negative 11. So the very first thing that we have to do, obviously, get rid of 5, right? Subtracted by 5, subtracted by 5. This 5 is going to cancel out this one. Be careful about here. I do have negative 11 subtracted by 5. It's going to be negative 16. Be careful about that. So what do I have so far? That was my first step. The second step, negative 4x is equals to negative 16. How I can get rid of the number beside the x itself? Remember, negative 4x. So what is the extra one? It's negative 4. It's not 4 itself, it's negative 4. So it means that I have to divide both sides by the coefficient, which is negative 4. Let's do that. So divide both sides by negative 4. I prefer to use the parentheses because I don't like to some kind of get confused at this point. Negative 16 divided by negative 4. Obviously, negative 4 is going to cancel out the negative 4, but at this point. If you remember, I told you that negative times negative is positive. We do have the same rule about division. Negative divided by negative is also going to be positive. So at this point, what do I have? Negative divided by negative, they're going to cancel each other, or we're going to consider as positive. And 16 divided by 4, which is 4. Still, x is equals to 4 itself. So as you just saw, nothing has changed that much. The only thing that I have to be careful is the negative number. What would happen if I have a negative number? The only thing that I have to be very, very cautious is the negative sign. What would happen if I divide one number or multiply number by negative itself? So what would happen if I do have variable on both sides? So at this point, we do have maybe a little bit another step, which we cannot call it as a step. It's just a way, again, that we do have it as isolation. So if you remember, in our previous question, it was, for example, x plus 3 is equals to 7, 2x plus 5 is equals to 11. It means that when I do have one expression in one side, the next side of our expression is just a number, okay? So I shouldn't have done anything, some kind of special with that one, but right now, I do have two expressions, two full package expressions that they're going to be equal to each other. So somehow I have to make sure that move all of the x's in one side and also move all of the numbers into another side, and after that do other operations, which is about addition, subtraction, multiplication, or division. So let's look at this question. At this question, I do have 3x plus 2 is equals to 2x plus 7, right? So the very first thing that would reach to your mind is that, okay, I have to make x isolated, right? It means that either I have to move all of the x's from right side to left side, or from left side to the right side, right? So let's just consider that 3x is on the left side, and I'm going to move everything from the right side to the left side. If you remember, when we are doing when we are trying to get rid of something, we are going to do the subtraction. When we are trying to add something, we are doing the addition. So at this point, I'm trying to get rid of 2x from right side. But I also have to be careful that when I'm doing that with the right side, I also have to do the same thing with the left side. So what do I have? I do have negative 2x, because by this way, this 2x and negative 2x are going to get cancelled. And I do have negative 2x over here. So my first, I have to say 1 prime, my first step is going to be find a way in order to make x still isolated. So I do have x plus 2 is equals to 7 itself. Okay, that's simple. X plus 2 is equals to 7. I know how we can do that, right? I do have positive, I do have positive 2, I do have the add with 2, so I have to do the inverse operation. What is the inverse of addition? Exactly, it's a subtraction. So I have to subtract 2 from both sides. Subtract by 2, so this 2 is going to cancel out this 2. X is equals to 5 itself. Simple. So again, look at this. About the first step, I have to subtract 2x from both sides. So 3x subtracted by 2x is going to give me this. And after that, I have to do this one like this, and that's my answer. Another thing that you guys have to be careful is about re-evaluate your answer. Imagine that I do have an equation and I find a number, right? So there should be a way in order to see that, okay, that answer is right or not. I would like to double check my answer, because there were so many times I've seen so many students that they found an answer and some kind of seems logical to them, but at the end we found that the answer was wrong, because probably they forgot to some kind of check their negative sign, they some kind of forgot to do the addition or subtraction, or even they did it wrong. So we do have one last step that I tell my student, I ask him to do it all the time. But whenever you find an answer, try to reevaluate it, try to check it, that whether your answer is going to be fit inside that specific question or not. So at this question, what did we have? We have 3x plus 2 is equals to 2x plus 7. Whatever number that you find, if you put it on the left side, should give you something. And if you put it on the right side, should give you another thing. By knowing the fact that left side and right side are the same, you can tell that, okay, I did something right, because my right side of expression and left side of expression are the same. So what do I have over here? I do have x is equals to 5, 3x, 15 plus 2 is equals to 17. Okay, this is a number. 2x plus 7 is equals to 10 plus 7, 17. Right now, I'm 100% sure the number that I found was right. The way that I did was completely right. I'm going to get the full mark. So after that part, we do have some kind of distribute before combining. What is that? If you guys remember from our previous videos, we had a couple of rules in the expression and in the terms itself. The very first rule was that whenever you see A times, by the way, when you see parentheses and nothing between, is actually multiplication. B plus C, if you want to get rid of the parentheses, or if you want to use the distribute rule, you have to multiply A by B, and you have to multiply A by C. So you have A times B plus A times C. One thing that I tell my students all the time is that it will be better to get rid of parentheses at the beginning, because parentheses is there in order to help you. Instead of just writing down AB plus AC, it's going to factor, they are going to talk about in the future, by the way. They are going to factor A and try to simplify everything. Again, they're not going to change the question, they're just trying to change the way that they're writing down something. So at all the time, when you have equations, or when you have any other kind of equation, it could be a simplification, it could be anything, try to get rid of fractions. By getting rid of the fractions, you have everything. You have the full package in your hand, and you know what you should do with them, right? So let's look at this question. At this question, I do have 2 times 3x minus 1 is equals to 14. Based on the distribute rule, I know 2 should be multiplied by 3x, 2 should be multiplied by negative 1, so I do have 6x subtracted by 2 is equals to 14. One thing that I have to mention is that maybe it would be a question for some of you that, okay, how did you find 2 multiplied by 3x? How did you find that it's 6x? For example, why it's not another number? Let me give you an example. So I do have 2 multiplied by 3x. If you guys remember, okay, multiplied by 3x. If you guys remember, 3x was actually 3 times x. So I already have 2. So 2 multiplied 3 multiplied by x. And if you guys remember, we had another rule that a multiplied bc actually can be written as ab multiplied by c. So it means that at this point, instead of just having 2 multiplied by 3x, I do have 2 multiplied 3 by x. This one was 6. I do have 6x. The good thing about the multiplication is that you can just change the number as long as the only thing that you have is multiplication, by the way. So at this point, what do I have? I do have 6x minus 2 is equals to 14. The rest is simple, right? We have negative 2. We have to remember about the two-step equation. We have negative 2. Somehow we have to get rid of it, right? So negative 2, the inverse operation is what? Positive, it would be addition, right? So we have to add both sides by 2. So this 2 is going to cancel out this 2. This 2 is going to be what? It's going to be 16. So 6x is equals to 16. I do have 6, which is the multiplication with x. I have to get rid of that. Divided by 6, divided by 6. At the end, my x would be 2.67. So right now you have to use the calculator, or you can just write it down as a fraction. It's simple. So one common mistake that I see sometimes the students would do is that they know what they should do, but the thing that they're doing is that they're not going to do it right. They're not going to do it completely. What does that mean? So we do have 2 times 3x minus 1. For sure, we know that we have to multiply 2 by 3x and minus 1. So they're going to do that. Okay, we are doing the multiplication, but not all the way to the end. They are going to multiply 2 by 3x, which is 6x, but they would forgot about negative 1. So one of the reasons that I ask you to double check your answer, to reevaluate your answer, is for this time. Because if you don't do that, how you're going to see your answer is wrong? So if you do that one, you have 6x, instead of subtracted by 2, it's going to be subtracted by 1. Obviously, your final answer is going to be wrong. So please be careful. And again, if you're careful, try to do the double checking. Try to reevaluate everything at the end. So we talked about this part, and let's move to another one. So we talked about the equation, and we saw that, okay, I do have an expression. That expression is going to be equal to another thing, and based on some kind of mumbling jumbling and the ways that I know, some rules, I can find the number itself. But what would happen if I do have inequality? It means that right now my x is not going to be only one number. My x is a range of number. And the only thing that I know is that one side is expression, another side is expression, but they're not going to be equal. One side is either smaller than or bigger than, smaller than equal or bigger than equal. Those four some kind of signs that we are going to talk about it. So if you do have this kind of condition, what we should do? So again, everything is going to be like equation. But at this point, instead of just only finding one number, for example, x is 3, x is 4, x is negative 2, you're going to have a range. It means that x is smaller than 2, x is bigger than negative 5. So let's see, what does that mean exactly? So inequality means that actually we are going to compare the values using the symbols. It means that either they are greater than or less than, greater than or equal to, less than or equal to. For instance, this example. x plus 2 is smaller than 10. So the thing that we saw was that x plus 2 is equals to 10 in equations. But right now, I'm seeing something like this. So your symbols are one of these fours. Less than, greater than or equal, less than equal. By the way, what is the difference between the less than equal? So for the first part, you see that 5 is smaller than 9. Or maybe you can have x is smaller than 9. They're not going to be equal. It means that whatever number that you have should be smaller than 9. The 9 is not included, is excluded. So when we say that x is smaller than 9, actually we are talking about 8, 7, 6, whatever number that is smaller than 9. But when we are talking about x is smaller than or equal to 4 or equal to 9, actually we are saying that x can be numbers smaller than 4 or 9, and x can be the number itself. So the only difference between these two parts or between these two symbols is one thing, that the right side of expressions, either it's included, we call it as equal, or not included, which we call it as excluded, which we call it as smaller than or bigger than. So that was the only difference. It's not that hard, but it is very important. So let's see how we can visualize it, because the thing is that when we are talking about inequalities, actually we are talking about the range of numbers. So it is very important for us to know when we are talking about the range of numbers, where are they? I mean, how we can find them, how we can see them. So when we are talking about these symbols, when we are talking about smaller or equal, when you're trying to show it on the line numbers, which we call this one, these two lines that when they do have something on them, we call it as the line numbers. If you're trying to show them, use the open circle. Open circle means that excluded. It means that your variable is not going to be as the same as the right side of expression. But when we do have the closed circle, actually means that your variable is that number includes inside your variable. Your variable can be as the same as that number as well. So for instance, when we are talking about examples, when we say that x is bigger than or equals to 2, we are talking about something like this. As you can see, it is included. So whatever number bigger than 2 can be considered as this one. When we are talking about x is smaller than -1, we are actually talking like this. But one thing that we have to be careful is excluded and included itself.